This problem is about removing a specific value from a list and then returning the number of remaining elements. And so the spec says that we must remove the elements in place, and that just means that we are not supposed to create a new variable with the reduced list, but we are just supposed to kind of modify this list itself. And it says that the order can be changed, and we need to return the number of elements which are not equal to the value. So the first intuition is that we kind of want to iterate over the list, and then if num is equal to the val, then we would want to kind of use the remove operation on the num itself, and then return the length of nums that are remaining. And the problem here is that when we call remove on an element that we are iterating over, then that kind of breaks the list because we are changing the length of the list, and which means that we might not actually get to the end. So you never want to kind of modify a list in place using this kind of loop. And so a simple fix is, instead of iterating over nums, we want to iterate while there is the value in nums. And so this will do a linear scan on a list and then check if that value is present, then we will enter this loop. And so then if we don't even need this if statement anymore, because then we will just be calling remove on the value and then returning the length of nums. So if you run this, then it should pass the test cases. And the only problem here is that when we call remove, we are doing a linear operation because say if we have a list that contains 1, 2, 3, and our target val is 3, then if val, it will detect that 3 is in the list, and then when we call remove on it, it will have to do a second linear scan, starting from the first index. So we'll go from 1, 2, and then 3, and then remove 3. And so you're kind of doing a linear operation inside of another linear operation, and that means that we have a quadratic time complexity. So we can do better. If you go back to the spec, it says that we can change the order of the elements, and specifically that the remaining elements are not important, as well as the size of nums. So currently what we're doing is we are completely removing any element that is not, that is equal to val, and then we're returning the length. But we don't need to actually remove the elements themselves, as long as the elements in nums that is not equal to the val all come before it. So for example, if we had 3, 2, 1 and the val was equal to 3, we could simply set it or create a list such that you have 2, 1, 3 or 1, 2, 3, and those would be valid because the number of non-val elements is 2, and the first 2 elements is not equal to, does not contain the val. So that means that, firstly, we know that we cannot use the remove operation because it is a linear operation. And so we don't want to do that. And we do know that we are going to do a single pass. So we will bring back for num in nums. And we want to keep track of how many or what k value is. So we'll be setting that to 0. And then we will at the end be returning just k, because now we're no longer actually going to be removing elements from the list, but we're actually just going to try to overwrite nums in a way that we don't have the val in the first k elements. And the intuition here is pretty simple in that as you're doing a linear pass, so as we go from like 3, it detects that it is a val, which means that we want to kind of overwrite this. So what we can do is, instead of trying to check whether or not something is a val, if we know that the first k elements has to be non-val elements, then we can simply check for any value that is not equal to val, overwrite that k index with that value. And that means that we will naturally be overwriting any elements within the first k elements that is equal to the value. So if num is equal to, well, not equal to the value, then we can set nums of k. So we're targeting the k index, and we're going to set that equal to the num. And then we're going to increment k. So we're going to do k plus equals 1. And so what this is doing is it will pass, and so it will find 3. It is equal to the value, so we'll skip this. Then we will go to 2. It is not 3. Therefore, we're going to set nums 0. So we're now going to be overriding the 3 that we just saw with 2. And then it's going to go and increment k to 1, and then we'll be going checking 1, and 1 is also not equal to val. So that means that then we are going to be setting the first index, so that is 2 to 1. And then that will be the end. So the first 2 elements will be non 3 elements, and so we will end up with a list that is actually just 2 1 1, and that is okay as long as the first k elements, which is 2, is not equal to 3, and it doesn't matter what order it is, then this is still a valid solution. So if you run this, then it should pass, and this would be the most efficient solution, as we're not when we assign something directly to an index, that is a constant operation. So this is just O1, and this is the only linear operation. So that means that this is kind of the only way that you can achieve optimality. And so that's all for this problem, and thank you for watching.